Yes, hello. My name is Anniken. I joined the field trip this summer mainly to get some data for my master thesis, which I'm working on at the moment. And when we were there, we did collect lots of different volcanic rocks, both basalt, but also different xenoliths. But then for this thesis, I've decided to continue only working with the peridotite xenoliths because I had to narrow it down in some way. Unfortunately, I've not been able to do any analysis of them yet, so I don't have much results to show you. But I thought I would tell you what I've done so far and also introduce you to what my plans are. So the aim of the project is to look at the more deeper mantle evolution, because this is thought to be the source of the Bockfjord volcanic basalts. And therefore we need to understand the source better and also look at the longer term evolution of the entire continental crust. So the first thing that I would like to do is to construct a new geotherm of the area and estimate the lithospheric thickness. This has already been done back in the 80s. I'll come back to that later, but then there are some new methods and I'd like to do this again. In addition, I will do some estimations of the age of the lithosphere. And then the third aim is to calculate the composition and fraction of the melt. So this summer, we, as others already have described, we were in Woodfjorden, and the Bockfjord volcanic complex outcrops mainly 3 different places in this area. And we visited all these three places. First, the Sverrefjellet, the ones we spent the most time at. That's where these pictures are from. You have different types of outcrops, and all from, yeah, it's been previously said as well. You have more these outcrops of where the xenoliths really stick out, and other places where it's platy and maybe there's not that many xenoliths, so it varies a bit. And during this field work, we just collected a lot of these rocks. From the scree slope, you see that it was easy to just pick up the nodules, and we did, and we collected lots of them. I might have over-exaggerated a bit when I put up these numbers, but I think we collected like 2 or 3 of like these really big bags, estimation of maybe 100 nodules, something like that. At Helland-Hansen, we also went there to the main outcrop, where we collected a few nodules and samples from close to the source, but then also a lot of them from the delta plain, which is most likely eroded material from this source. Here there's also several crustal xenoliths too, but I've decided to not focus on them. Do you want to say something? And I think there's one more as well, a larger xenolith at the back. Can I look at that later? And then we also made it not to the top of Sigurdfjellet, but to a gully that runs from Sigurdfjellet. We scouted for rocks, but we did not really find the volcanic ones until we suddenly came to this one gully where we luckily found them. And from here as well, we collected a handful of both xenoliths and other volcanic rocks. So then, all in total, we had lots of samples, but then I've narrowed it down to about 31 samples from Sverrefjellet, and then 5 samples each from Helland-Hansen and Sigurdfjellet. this picture illustrates like what it was like at the end of a normal day in the field, where the backpacks are full and then as much as we could carry, and maybe a bit more as well. Further back in Tromsø, Ulla Rinman came with all our samples. We estimated like, I think 800 kilos during the entire field season. So that was a lot to carry, and also a lot to open up and start sorting out. So what I've done is sorted out these rocks, which I just mentioned, and then started preparing for analysis, where I've been cutting them for thin sections. They are sent, but I don't have the ready thin sections yet. And then also crushing them to a powder. That's what I'm doing these days. During the sorting, I discovered more of that. There's different textures in the xenoliths. This has been described earlier in different papers. It's not something new, but it is a clear sign that there has been some fluid circulating in the mantle, and this must be better understood. And then, so the 4 groups that I've started out with in the sorting is the normal coarse granular with mostly olivine. And then we have this more porphyroblastic texture. But then the very interesting ones are the composite ones, where some of them are more homogeneously distributed, pyroxenites and more olivine rich, but then some of them are as well laminated. So for the further work, as I mentioned, I would like to establish a new geotherm. Amundsen did one back in 1987, which is the one that has been used until now. And that one was based on garnet websterites, pyroxene granulites, and spinel laserlites, so like a broad amount, different types of rocks. This graph that I shown is what he published based on the garnet websterites. And they figured out through this study that that it's a relatively hot geotherm, rift associated, and that the crust is relatively thin, only 27 kilometers. But now we have some more modern techniques for the pressure and temperature estimations, and hopefully this will give a more precise, data and add with some additional data to work with later on. So for estimation of the lithospheric age, I will be working with the uranium osmium isochron method, because this one is known to work well for mantle rocks. There has actually been one study doing this earlier that was just published in 2022. They used uranium osmium in addition to some other isotope isochrons as well. But they only have 3 samples with the uranium osmium. So hopefully I'll be able to do some more to add data, and hopefully see, hopefully it matches well with this one too, so that we are more certain that it's correct. So in this study, these people with the uranium osmium found the age of 457 plus minus 3.5 million years. And they considered this as some upper boundary for the delamination of continental crust, where you also had some partial melting and uplift of the lithosphere. So it'll be interesting to dive deeper into that. For figuring out more of the composition and fraction of melts, there is this quite new modeling tool where it can the input of pressure, temperature, and the volatile contents can give you the composition, the fraction, but also the corresponding electrical conductivity. As far as I know, this has not been done for the Bockfjord volcanic complex. So that will be done. And then, well, because we get the corresponding electrical conductivity, maybe this could be linked to some geophysical data. I think maybe that your MT work is a bit too shallow for these rocks, but I will see if I find something interesting to compare it with, or maybe. So maybe exactly. So maybe that could be used or maybe for some future MT work that goes deeper. Maybe this could be interesting too. That's what I've done. This is the references for the works that have been mentioned. Thank you very much. Yeah, any questions? Yeah.
A comment.
Yeah.
Mental velocity, we could current temperature, compare that to the fifth and then figure out how the temperature change.
Yeah, that would be great. Yeah. Nice.
I'll be in touch.
Perfect. Okay. Thank you.